Hello everyone, here the question says the maximum frequency, okay, frequency and the minimum wavelength of X-ray produced by 30 kilovolts electron. So electron volts. So the voltage is going to be produced by the electrons. The potential difference is going to be produced by the electrons. Okay, this is going to be the energy here, right here. This is going to be the energy. Okay, energy or work function, whatever may be. Okay. So now to find the maximum frequency according to the Einstein's equation. Okay, what is the Einstein's equation of photoelectric effect? Okay, so we have to see about H mu. Mu is the frequency, right? Is equal to the work function pi plus kinetic energy. Okay, kinetic energy. So we have to find maximum. Oh, okay, here minimum wavelength. So minimum wavelength. Whenever the minimum, what is the minimum wavelength to produce to distribute an electron is going to be. So when the kinetic energy is going to be zero. So whenever light of h mu is going to incident here, so that the electrons present inside this metal get some get some energy and just get out of the surface of some metal surface. Okay, so the kinetic energy is going to be zero after it is exited. Okay, so if more energy is going to produce incident here, then the kinetic energy will be the energy. So the work function is the energy to come out. Okay, out of the metal, and the extra energy will be in the form of kinetic energy, so that the electron will be run away with the kinetic energy. So extra energy. Okay, so total energy is this. Okay, from this energy to get out it as work function. So after getting out, if there is more energy, so even though getting out it has energy, so it is going to run away with a form in the form of kinetic energy. The kind of energy is going to release in the form of kinetic energy. To find the minimum wavelength, so the minimum wavelength can be kinetic energy is going to be zero. So the minimum wavelength which is required to exit this electron. Okay, so that's the thing here. So work function, so yeah, work function is going to return as electron volt. Okay, work function is nothing but say electron volt. H mu can be written as hc by lambda. Since they didn't ask about the minimum frequency, this is a maximum. So this is zero when there is minimum. Okay, so we can able to find only the wavelength using this equation. Hc by lambda is going to equal to, yes, electron volt. So this psi is nothing but work function can be written as electron volt. So this is the formula to find the lambda. So lambda can be written as, yes, this is lambda is going to be the wavelength, minimum wavelength. Okay, this is very important. Minimum wavelength hc by electron volt. Okay, so this is the first thing we have to understand here. So to find the maximum frequency, we are going to use the Einstein's equation here. What is the Einstein's equation? H is equal to mc square. Instead of writing that, h mu. So energy formula h mu. So here we can able to find the maximum frequency. So energy here is the form of electron volt. So electron volt is equal to h mu. After further, to find, we have to find this maximum frequency. So frequency can be written as, yes, from this equation frequency can be written as mu can be written as electron volt divided by the Planck's constant. H is nothing but the Planck's constant. So from these two we are going to find the answer. In the next page, let's move to the next page. So to find the lambda is nothing but this is the minimum wavelength, that is nothing but okay, let's look at the value here, hc by electron volt. Move to the next page. hc by electron volt. Okay, to find the minimum wavelength, simply substituting the values. So minimum wavelength, which is going to equal to Planck's constant, is nothing but 6.66 into 10 power minus 34. Minus 34 is known as Planck's constant, that is h. and c is nothing but the velocity of the light is 3 into 10 power 8 meter per second. Okay, so which is going to be divided by electron, the value of one electron. Yes, the charge present in one electron is going to be 1.6 into 10 power minus 19 coulomb. Okay, into this is volt which is going to provide it, voltage is going to be here, yes, 30 kilovolts. 30 kilo means 30 into 10 power 3 voltage. 30 into 10 power 10 power 3. Okay, this is kilo, right? That's why I'm written like this. Just cancelling this 1, this 10, and this, yes, this is going to be 0.8, 2 tables. This is going to be 3.3 here. Okay, everything is cancelled. So 10 power 3, 10 power 3 can be written as nothing but 10 in 10, nearby 10, sorry, 1, 3 zeros. This is going to be 10 power 3, 3 zeros. And here this is 8 0, 1 2 3 4 5 6 7 8. So from this 8 zeros, so near 1, this is going to be, okay, 1 1 cancel, this 0 this 0, this 0 this 0, remaining 1 2 3 4 5, remaining is going to be 5. That's what I'm doing here. Remaining is going to be 10 power 5, right? 3 zeros cancelled. Here 19 zeros is going to be cancelled. So 34 34, what is rolling on here, 34 minus 9 19, so this is minus, and this is going to be plus. Okay, when you move up this is going to become as plus. When you move, that is multiplying 10 power 19 and dividing with 10 power 19, so this get cancelled, so I'm not showing that here right now. Okay, this is going to be 1, 19 19 19 19, so I'm just scribbling here, right? Yes, by subtracting, this is going to be 2, this is going to be 14, this is going to be 5, and remaining 15, so this is going to be cancelled. 10 power minus 15, 10 power minus 15, that's minus 15. So anything else, nothing. So we'll move on the next step. Yes, lambda is going to be equal to, now the remaining thing is 3.3 can be written as 33. So 3.3 can be approximately equal to 32. So okay, 3.2 approximately equal to, so this can be approximately equal to 3.2, that is 3.3 can be approximately written as 3.2. 3.2 can be written as 332 into 10 power minus 1, so into this, so this can be written as 3.2 approximately. To find the approximation, 3.2, 332 into 10 power minus 1, here 10 power minus 15 is there, 10 power minus 15. Okay, next one, and next 10 power 5 is there, 10 power 5. Okay, now the denominator, moving to the denominator, this is going to be 0.8, 8 8 into 10 power minus 1, 0.8 can be written as 8 into 10 power minus 1 and into 10, right? Overall, now getting to cancel, so 8 4s are 32, right? So yeah, yes, yes, here we are going to cancel this, these two things and become right as 1, 10 power minus 1 into 10. Okay, and this is going to be 5, right? This is 5, and this is going to be 10 power minus 10. When you cancel it, it becomes 10 power minus 10. Okay, okay, now this is going to be the lambda, which implies the lambda, the remaining things is going to be 4 is equal to 4. Okay, this is 10 power minus 1, 10 power minus 10, yes, 10 power minus 1 and 10 power minus 10 into 10 power minus 11, which can be written as, which can also written as in a nanometer, multiplying and dividing with 10 square. So dividing with 10 square, that is 100 into 10 square, So this is 10 square. So which produces 0.04 into 10 power minus 9. 10 power minus 9, or picometer you can able to divide and multiply. 40 picometer can be written as 40 picometer, sorry, 40 picometer. Picometer can be, the lambda can be written as 40 picometer. In other terms, okay, it can be written as, so here it is written as 0.04 to 10 power minus 9. That is, the lambda can be also written as 0.04 nanometer. Nanometer. So this can be written as 40 picometer or 0.04 nanometer. So let's see what is the given value actually. Okay, let's move on to the page. There's options. Yes, here, first option. 0.04 nanometer. They are given in the nanometers. Okay, they are given in the nanometers. Hertz means frequency. This is going to be the wavelength. Wavelength is given in the nanometer. So from this, you can able to get it 0.04 nanometer. That is first option. Is going to be the correct answer for this question. If you want, the first answer is the correct answer for this question. But I'm going to try to find the frequency also. Okay, I'm going to try to find this frequency also. If you want, you can able to watch it, otherwise you can able to skip it just like that. Okay, to find the frequency, I'm just moving to the next page. So to find the frequency is equal to electron volt divided by Planck's constant. So mu, that is frequency, electron, the value of electron is equal to 1.6 into 10 power minus 19 coulombs into the voltage provided as per the question. As per the question is 30 kilovolt. So kilo means 10 power 3. So 30 into 10 power 3 voltage, 10 power 3, since it is in kilo. So by, so Planck's constant 6.66 into 10 power minus 34, minus 34. So anything else to cancel here is, yes, 3 2.2 saw 2.23 tables. This is going to be 10 in the 3 tables. Okay, as well, so 34 minus 19 again the same thing is going to be 15, right? 15. So this is going to be cancelled, this is going to be cancelled. Yeah, 10 power 15, 10 power plus 15 actually. So otherwise you can able to write here 10 power minus 50. So both are going to be same, nothing here, the minus 50. Okay, nothing is going to be wrong here, both are going to be same. I'm just writing here itself 10 power 15. Okay, and anything else cancels is 1.1, and this is 0.8, 0.8. So remaining value I will be writing the next line, that is mu is equal to 0.8, it can be written as 8 into 10 power minus 1 into the, here the thing is 10 power 15, so which becomes 10 power 14 later. So 10 into 10 power 3, so by 1.1 can be written also, approximately 1.1 approximately can be equal to 1. Okay, so the denominator I'm not going to consider the denominator, this is approximately, it is going to, I'm just doing here 10 power 3. Here the only the tens you can able to see here, only the tens. So 10 power minus 1 plus 15 plus 1, this is 10 power 1 actually, plus 1 plus 3 as per this. So minus 1, 15 minus 1, 14, 14, and again this is minus 1 get cancelled, again it's going to become 15, 18, 10 power 18. 10 power 18 can be, yes, 8 into 10 power 18, so which is approximately equal to 8 into 10 power 18. Approximately the mu is approximately equal to 8 into 10 power 18. Mu is approximately equal to 8 into 10 power 18 hertz. Since it is a frequency, the SI unit is in the hertz. okay, where it is anything, so same first option. So you can able to note it down, I'm just erasing here right now so that it is clearly visible. So 7.24, right? 7.24. So it is approximately equal to 8. And none of the options is going to be same. So first option same correct answer for this question.